In my previous video, I showed how to download and install Llama.cpp. Then I got a version of Qwen 35B running on my local PC. In this video, I want to explore more deeply the capabilities and intelligence of various types of models. Specifically, I'm going to stick with Qwen 35B and look at different quantizations and Finetunes. This whole process is called benchmarking, and so today we're going to be benchmarking locally. The first step will be setting up the benchmark. For this video, I'll be using Hermes agent to automate a lot of the processes, but you can do this manually as well. The second step will actually be running the test and then monitoring the live progress via log files. And finally, I'll analyze the results, break down what went wrong, any issues I had, and takeaways to learn from. Whenever we run LLMs, we want to get the most bang for our buck. That means running the most intelligent models at the fastest speeds with the least amount of overhead in terms of VRAM, compute, or any other resource on our computer. Quantization is one of the main ways that we accomplish this. It'll shrink the weights of the model, and therefore a 36B parameter model, for example, will go from 72 gigabytes at full precision all the way down to 21 gigabytes at a reasonable middle ground. This means faster bandwidth, less memory footprint, and overall, it maintains most of the accuracy of the full precision model. Fine-tuning is a little bit different from quantization. Base models are generalists, and so fine-tuning steers them towards specific domains, whether that's code, math, or reasoning. The reason I'm mentioning this here is that I will be talking about a fine-tuned model of Qwen in this video. However, I'm not going to go into the details of actually how to perform this, and that's not the topic of today's video. The Qwen series of LLMs is incredibly popular, and so there are many fine-tunes and quantizations available now on Hugging Face. Two of these, which I think are worth mentioning, are Hermes and Darwin. Hermes is basically a fine-tune which optimizes it for agentic performance, and it does so by training it on Hermes agent execution traces. What this all means is that if you're going to use a Qwen model on Hermes, it makes more sense to use one that is natively trained for Hermes. While Hermes is trained on Hermes agent traces, Darwin is trained on Claude Opus. This makes it very good at reasoning, and in fact, it ties a much larger Qwen 397B model specifically on GPQA Diamond. This is a benchmark that measures its reasoning capabilities. While ultimately, the most important thing for a model is its performance in real-world use cases, it is useful to benchmark them in order to make apples-to-apples comparisons across different fine-tunes and quantizations. Benchmarks measure a model capability on a standardized task. For example, MMLU Pro measures multi-domain knowledge across a wide variety of subjects. GPQA and its cousin, I suppose, SuperGPQA, measures graduate-level reasoning, and in particular, in this video, I'll be covering its ability to perform physics calculations, which is heavily reasoning-based. Before I show how to actually do this, I want to cover some of the results I've already obtained. So specifically, I took a subset of SuperGPQA, and I took a subset that is only physics questions. The model I'm using is Darwin 36B, Opus, and the quantization is Q4KL. This fits on my home machine. I gave the same model, the same questions, and 3 different token budgets. As we can see, as we increase the token budget from 4K to 8K to 16K, the accuracy improves remarkably. However, as we go further down the chart, we can see that the reason for this performance difference is due to no answer failures. The model simply ran out of token space, and by giving it more room to think, it was able to accomplish more tasks successfully. Darwin 36B is fine-tuned specifically for reasoning, so I would expect it to perform very good at reasoning tasks. It's also a reasonably good-sized quantization. Q4KL is a good sweet spot. However, in my last video, I downloaded a quantization of Qwen 35B, which was not fine-tuned in any way, and it was rather small, roughly 12 gigabytes. This makes it good for fitting on a single GPU. However, there was an open question about its capabilities regarding reasoning and intelligence. This is what I want to test in today's video. So here I just have VS Code open. This is very similar to what I did last time. I have my terminal here, and I run a Llama server command. It's going to open this Qwen 3.6 35B model. This is the IQ3 quantization that I couldn't pronounce last time. And basically, it's a very small model, and we want to test its capabilities. So if we scroll down, we should be able to see that it is already running. I made sure that there's no issues this time with memory. And what we want to do is go into Hermes agent and ask it to actually benchmark this. So here I've gotten Hermes agent running. If we scroll down, we can see that the default model I have configured is actually Darwin 36B. So I do need to change this. And the way I'm going to do this is actually to not use a local model for the agent itself. So I'm going to split my workload, and maybe I'll be violating some purist principles, but I will use DeepSeek V4 Flash to actually coordinate everything. Meanwhile, the local server running Qwen is going to be the one actually doing the benchmarking. This way, we can absolutely ensure that there's going to be no mixing of any context or memory, and so we know the agent will not be actually cheating. So in Hermes, we just type model DeepSeek V4 Flash. You may need to configure this, and you don't have to use DeepSeek. This is just an example. But we'll hit enter here, and now it'll switch to the basic model. This routes through the API, so you do have to pay for API credits. I signed up specifically with DeepSeek, so I'm not using OpenRouter in this case. OpenRouter is great, and I highly recommend it. But if you want to get cache reads, like you can see here, which are very inexpensive, you're probably going to want to go directly with a provider. Tangent aside, let's get into it. So we have our server running, and I will just use plain language and say, I would like to benchmark my local LLM running on the local server. Please use GPQA physics. And so I already have a file on my computer, which is specifically for GPQA physics. This was also produced by Hermes. If you don't have that, you can just ask and it will do so. And I had no issues getting that set up. So my prompt wasn't great. It's basically asking me to clarify what I mean, but this is what's nice about agents is they will often ask you clarifying questions. In this case, I want to do one. And it'll ask me to run a command. So I'm going to allow for this session. Always watch what commands your agent is running though. This is on my home computer, and it could do things like remove files or delete your whole computer if you're not careful. I haven't actually had an issue with that, but I've heard horror stories. So always be cognizant of what your agent is actually doing. So I basically clarified that I wanted 100 questions at 16K context in order to make it consistent with my previous tests. And it's asking me if I want to change that because it's going to take a while to run. One of the reasons it's going to take a while to run, though, is that concurrency is currently set to 1. In my previous tests, I was able to get concurrency equal to 4, and I had no issues. This does take up more memory for context, but with my machine, it's no problem. So I'm going to ask it to set concurrency to 4. Because I'm setting concurrency to 4 in my benchmark, I'm now realizing that the server I started actually did not have that as a setting. So I do need to edit that. And so if we look, there is the NP flag, and right now it's set to 1. This just needs to be set to 4, and then I'll have 4 parallel threads. And that will basically fix the issue. So now I'll just tell Hermes that I fixed it, and it should proceed with the benchmark. So here it's just asking for final permission, but everything looks good. We have 100 physics questions, max tokens is 16K, concurrency is 4. This is the correct model. This is the port that it discovered on its own. I actually had to change the port, but I didn't have to do that manually. Hermes figured out which port to use, which is another thing that's nice about using these agents when you have to deal with the minutia of configs. It just makes things a little bit easier. There will be a log file, so we'll be able to monitor it as it proceeds to make sure things are actually working. And otherwise, yeah, we're good to go. So let's just say go. All right, so I just copied this command here, this tail command, and I went to a different terminal and pasted it in, and it'll keep a running log. It's literally monitoring the logs that are being produced by Hermes. So we can see here as each question comes in, that we can see if it's correct or incorrect, and it tells us the time it took to complete and gives us lots of useful information. So everything's working properly, and I'll check in when it's done. All right, so the benchmark has finished running, and we got a surprising results. The accuracy for the normal 35B Qwen was 89%. We can compare this to the Darwin results that I showed earlier, which was only 79%. So this is actually significantly better. I asked Hermes for possible reasons why this might have occurred, and it does seem like the Darwin fine-tune reasons for a lot longer, perhaps because it's trained on those opus traces. So it had 12 questions where it couldn't actually get an answer. It hit the max context limit of 16K. If I was going to run this in the future, I would use a larger context window, but I did want this to run in a reasonable amount of time. This took me about an hour to get going. So this is just a small test, of course. In practice, we want to run very large benchmarks that would take multiple days. So maybe we can't get a perfect conclusion out of this, but let's summarize the results anyway. As we can see, the 35B IQ3 quantization got 89%. It used about 25% fewer tokens. It had no answer failures. And this shows that it is more than up to the task of doing these GPQA physics questions. In the future, I may test this in further detail. There may be issues with my setup or something that I've missed. However, in general, I would say this is an intelligent quantization. It fits on a single 16 gigabyte GPU, and it's about half the size of this Darwin fine-tune. For my purposes, I may switch to this going forward. I may test others in the future as well. And I'm very curious to see what other benchmarks this would do well on. If you have any suggestions or criticism, feel free to let me know in the comments. Otherwise, I will see you guys next time with another video. Thank you.